Hey, it's Mr. Shrum, and I just wanted to walk through these questions where you are tasked with balancing chemical equations. And I'll show you some shortcuts and how to approach some of these problems. Let me stop sharing so you can see. All right, so for the first question, it asks you which of these is balanced, and it happens to be B in this case, and I'll show you why, what's going on. And from what we learned in the previous lesson, there is the conservation of mass, and that means the atoms on the left-hand side of the equation has to equal the number of atoms on the right-hand side. So the number of atoms in reactants equal the number of atoms in the products. And a shortcut is to multiply this coefficient by the subscript for each atom. And that will give you the number of atoms on each side of the equation. So for calcium, you have 2 coefficient and a 3 subscript. So 2 times 3. So calcium, we'll write them out. P, O, and then that'll be our dividing line. How about that? 2PO, and still O. Okay. So multiply the coefficient and the subscript. So you got 2 times 3. That equals 6 calcium atoms on the left-hand side. You can check over here, 6 times calcium. The subscript is 1, so it's like 6 times 1, but it's just 6. That equals that, so we're good. P. So this one's a little tricky. You have, this is one molecule, but it has a subscript here. So you have 2 times 1, that's 2p, and then times the coefficient out front as well. So you have 2p times 2, 2 times 2, that gives you 4, okay? And then to check the right-hand side, we have 4p equals 4, 4 equals 4. Looking good so far. Now we have the O's. Now there are 2 O's on the left-hand side, so you have to keep track of those. So for the first one, we have 4 times 2 times 2. All right, so we have 4 times 2 because of the subscript here, and then times 2 for the coefficient out front. So what does that give us? That gives us 8 times 2, that's 16. We have 16 plus this one too. So you have 2 times 6 plus 12. That gives you 28 oxygen atoms. So that's a lot already. So let's see if that balances out on the right-hand side. So you have 10 in the first situation. So we have O equals 10. And then you have 6 times 3. What's 6 times 3? 18. You get 10 plus 18. That's 28. So you get 28 equals 28. We're all good. Now, for our last one, we have silicon. This one's easy, 6 on the left-hand side. And the right-hand side, we also have 6. So it looks like this equation is balanced. Cool. All right, let's get back to question 2. Now, is this equation balanced and in the lowest form? So another way you have to pay attention, or another thing you have to pay attention to with these chemical equations is you don't want any type of like redundancy, and they view, not they, but science in general, you just want to reduce the equation as much as possible. And to show you what I mean, I'll do this. We have 4 NH3, 2 N plus 6H2. Okay. So when you're all done balancing the equation, or you think you're all done, double check to see if you can divide out any number for all terms. And in this situation, we have 2, 4, and 6. All of those are divisible by 2. So just divide everything by 2. And that will give you 2 NH3 and 2 plus 3H2. Okay. So this is the reduced coefficient equation. So this looks a little more cleaner than this. And that's really the only thing wrong with it, quote unquote wrong, but you got it. Which equation obeys the law of conservation of mass? This just means which equation is balanced, okay? So think of conservation equals balanced. And we have two, well, let's just go. There you go. So D is the only one where the atoms on the left-hand side equal the number of atoms for each substance on the right as well. So you have 4 atoms of iron and then 6 atoms of oxygen. Methane burns in oxygen to produce carbon dioxide and water. Which of the following represents a preliminary unbalanced equation with the correct chemical formulas? So all this is asking is, can you just get the right representation without worrying about the coefficients? So you have methane, which is CH4, burned in oxygen. So you say plus O2 for oxygen gas. And then they produce carbon dioxide, which is CO2, and water, which is H2O. So which looks like that? This one. Methane burns in oxygen, so you have methane plus oxygen, and it produces, the products are CO2 and H2O. And a lot of that you'll just get used to after doing a bunch of chemical equation questions. Which chemical equation is balanced? Looks like D. Let's see why. For H2O. Hydrochloric acid plus. All right. Let me stop sharing real quick. Ta-da. Okay. So you can guys see that? Okay, so we'll write out P, or phosphorus, chlorine, O. Okay, so looks like we only have one P on the left-hand side and the right-hand side. Chlorine, 5 on the left-hand side, 5 times chlorine, so we get 5. So far we're balanced. H, we have 8, so 4 times 2 equals 8. Oh, sorry, we didn't check yet, but on the right-hand side, we have 5H plus 3. 5 plus 3 equals 8. So now we're balanced. Then for O, we have 4 on the left-hand side, and the right-hand side, we have 4 as well. So we're balanced. Cool. All right, now back to this screen. Which of the following is true for balancing equations? There must be an equal number of atoms of each element on both sides of the equation. Well, yeah, that was pretty easy. Yeah, it's A. Which statement is true about word equations with regards to chemical reactions? They provide the most accurate way of describing reactions. They are recognizable by speakers of all language. They provide a qualitative description, but not a quantitative one. They're just as useful as reactions described by. I'm going to go with they provide a qualitative description of a reaction, but not a quantitative one. It's easier to show that in chemical equations. What do these symbols in parentheses indicate? So you see this aqueous solution, the AQ, and S for solid or precipitate, whatever you want to call it. That tells you the physical state of each reactant. So it'll tell you if it's a liquid, a solid, or gas, and that can give you a clue as to what's happening in those equations too. In this equation, what should be the coefficient of the reactants and products? So here we go. So we have here, yeah, 9. So we have I2 plus O2 equals I4. Okay. So stop sharing. All right. So this one's a little tricky, a little trickier than the ones we've looked at before. But this is an unbalanced equation for now. We have I2, O2, I4, O9. So you can definitely tell what's happening. We need some balancing. So the easiest way to do this is to make this 9. And to put a 2 in front of this. So now we have 9 times 2. So for I and O, we have 9 times 2. That's 18 for O. On the left-hand side, then you have 2 times 9, which is 18 on the right-hand side. So that is balanced for now. Now we have to go back to the I. So now we have 2I4, or 2 times 4. On the right-hand side, we have 8 for I. So how can you make this single I equal to 8? Well, you can put a 4 in front of it. So 4 times 2 equals 8. So now we're balanced. Okay, and that's a good equation to practice. Step 1, if you have a situation where you don't have a lone product out here, if it's just one combined equation or combined substance, you can multiply the subscript here by the subscript here. So they kind of switch. So multiply this 09 by 2, and then multiply this 02 by 9. And that's how we get that balanced. And then once you get all that worked out, you can come back to this separate lone atom. And those are the easiest to adjust at the end of the problem. So step 1, multiply by the subscripts. Step 2, balance the equation by adjusting the lone atom. And in that case, that would be I. Okay, so you want to handle these first. And then once you get that sorted out and one of them's balanced, you can fix this lone atom. Cool. Now I think we have one more, and then we're done with this balancing chemical equations mastery test. So, which is the next logical step in balancing the given equation? Place the coefficient 2 in front of oxygen and nitrogen dioxide. So that is the easiest thing to do, or the most logical. And do I have a little more room? Yeah, here we go. Just got N2 plus O2. That combines to NO2. Okay. All right, here we go. So you can put a 2 here first to make that equal this. And now if we want to write out how many's on each side, we have 2, we have 2, and we have 2, and then we have 4. So this is balanced now, and now you just put a 2 in front of there. So now you have 2 times 2 equals 4, and that balances out. So here's that final one. Here, there's a little neater. Cool. But that is essentially how you balance equations. And once you understand and find a rhythm for it, it becomes a lot easier. So I hope that helped. And if you have any more questions, go ahead and email me, message me, and I'll help you out as much as possible. And until next time, have a good one and have a great rest of your week. Bye.